Welcome everyone to the first of our fall semester learning and retirement lecture series. When I was planning this series under the theme Engineering Risks, Disasters, and Corporate Behavior, I was partly prompted by incidents like the problems of Boeing jets, design flaws and negligent construction, the Volkswagen cheating on diesel emission measurements, the collapse of the Francis Scott Key Bridge in Baltimore, and other similar happenings. And just the other day in San Francisco, glass fell from a high level of the Salesforce Tower into the street below. Now, one would think that in designing and building a structure with glass installed hundreds of feet in the air, great precautions would be taken to make sure that such a thing never happens. So one does wonder when it happens, whether shortcuts were taken or materials were not properly installed or what happened. As it turned out, this series is a little bit shortened because one of our engineering presenters had to cancel, but I am delighted that we can hear today from a great expert in this field, distinguished professor from the Department of Civil Engineering. Dr. Abolhassan Astaneh is Professor Emeritus of Civil and Environmental Engineering and a 2013 Minor Faculty Fellow in Engineering Ethics and Social Professional Responsibility in the College of Engineering. He received an MS in Civil Engineering at Tehran Polytechnical Institute and both his MSE and PhD in Structures at the University of Michigan. His research and expertise are in structural analysis, design, earthquake engineering of concrete and wood buildings and bridges, failure analysis of buildings, bridges, and other structures, blast protection of structures, and protection of buildings, bridges, and other structures against terrorist attack. Dr. Astaneh has conducted failure analysis of several collapsed structures, including the World Trade Center towers, about which he is speaking today, and 6 significant bridge failures. And he has provided expert testimony to Congress and state governments and investigatory commissions. He's the author of hundreds of research papers, and in 1998, he received the T.R. Higgins Lectureship Award of the American Institute of Steel Construction, which is the most prestigious award in his field. He continues his research and publication and gives lectures and seminars on the subjects of structural engineering, earthquake engineering, and engineering ethics. It is a great pleasure to invite him to speak to us now on engineering aspects of the World Trade Center collapse. Hassan, go ahead.
Thank you very much, Donald, for that wonderful introduction. I'd like to welcome everyone to this webinar and thank the organizers, especially Camille, to so generously giving and helping me, advising me how to do it organized. And I hope everything well. As Camille mentioned, there is I will go through presentation continuously, and please there is a chat button. Please use chat button, and at the end of this webinar, I will, of course, be delighted to answer questions and hear comments, which is very important, probably more to me, equally or more important to hear from you. Especially, this is very emotional. It's not just engineering or scientific issue. We all have a lot of emotions attached to this project, myself, and I'm sure all of you. This is just this totally different project. Perhaps for me, it's my project of lifetime. Then after we exhaust the questions about the presentation, I hope I'm planting question now. I hope someone asks, what am I doing now that I'm retired? That would be a good question. So I will take the opportunity and just briefly tell you how wonderful it is to be at Berkeley, of course, and how wonderful it is to retire from Berkeley and have all these opportunities just for me because of being at Berkeley. That's my belief. With that, I will focus basically in this seminar on the engineering aspects of this tragic event and the studies that I did. And of course, this is very necessary, not only this study, but all the studies regarding this very serious and important structural engineering event, because we can learn from these events and try to make sure we don't repeat what happened here in the future. That's the entire engineering operation. Maybe science is the same, but engineering is really learning, especially civil engineering and structural engineering is very much intuitive and design oriented, and we learn from our mistakes in design. So with that, I'd like to mention that definitely this tragic event was caused by the murderers from the Wahhabi Muslims who came as terrorists and inflicted this tragedy on us and killed our loved ones. But when I go through this webinar and show you how engineers as well as corporates involved in this project did not follow really the ethics to put the safety of public ahead of every consideration, that should not be considered as I'm saying that these wonderful engineers and wonderful corporate people who are trying their best are responsible for this murderous act. It's only those Muslim Wahhabi terrorists who came and did this barbaric crime. I have all this. I have this slide in my all ethics presentations. This is my. I've been involved actually, as Donald mentioned, in bridges and buildings. So these are my bridge projects on the left. Down here is basically the expert witnessing I've done and failure analysis in court for collapsed bridges. These are the building projects I had. And of course, I've been involved in a lot of research at UC Berkeley, at Earthquake Engineering Research Center, and so forth. These studies and the webinar are dedicated to the memories of all victims of 9/11 terrorist attack and to the firefighters, police officers, and other first responders who so heroically sacrificed their lives to save others. Here is the North Tower, and you can see people, the airplane has hit, people are coming down, and the firefighter is going up. They responded very rapidly, and then, of course, after the South Tower collapsed, they were still in the North Tower and helping people to evacuate. And unfortunately, with the collapse of both towers, we lost 414 of the most honorable heroes and the best that humanity can offer on that tragic day, when the firefighters themselves also perished in the collapse. They went in, this is the highest, I think, sacrifice anyone can do. They went in a very vulnerable building, and they, more than 1,500 people who went in, including the firefighters, even a DNA was not found. This is the wall in the World Trade Center memorial at the site now. 2,753 innocent people perished at this site. In honor of them and never forget them, let's have a moment of silence. Thank you. The 9/11 2001 tragic collapse of the World Trade Center towers. At 8:46, first plane hit the North Tower. Here you can see on the right, it's being burned. At 9:03, almost 20 minutes later, the second plane hit the South Tower from the south. And about 1 hour after the South Tower was hit, it collapsed. And then, of course, about 1.5 hours after North Tower was hit, that also collapsed. I bring to your attention this picture on the right that everyone was surprised. This looks like avalanche of dust I will get to this later, why. When this building collapsed, the building turned into powder. That's the essence of really the core of why this building collapsed. So I'll get to that. And that's why conspiracy theorists have the field, they had the field day to say that, you know, this was explosion, demolition, but all nonsense, of course. I don't even give more than 3 seconds to them saying that it's all nonsense. Content of this webinar. First, I'll talk about design and construction of the World Trade Center. That is why these buildings so completely, so fast, and so devastating completely collapsed. So I spent time on it to show you why these buildings were unique. No building in the world is like these, and that's why they collapsed. The 2000 airplane attacks, I'll talk about that. And of course, my fielding investigation that I spent time from 2001 to 2002, funded by National Science Foundation to go to World Trade Center site in New York and start investigating. I noticed actually that Susan Gardner is in the audience. Hi, Susan. I just got emotional when I saw you there. Susan Gardner, when this happened, I knew this is very important. That was a Tuesday. I had a visiting scholar. I told him that go get all the books in the library. This is now noon on 9/11. And bring to my office. We go through everything we can learn about World Trade Center. Then I contacted NSF because we have a program, Learning from Earthquakes. And the program director, of course, knows me and we know each other and we go and investigate earthquakes. I told him that this is very important. This has to be investigated right away before evidence is gone. And he was kind and he said that we are going to actually announce proposals for 10 fields, not only structural engineering, but air pollution, this, that. And they did and submitted proposal. I submitted my proposal 2 days after 9/11. And Susan was the one who had the backache. I don't know if Susan, I should have said that, but I'm so emotional about what you did that I mentioned it, a personal thing. And she was standing, she wasn't sitting that afternoon, and she was helping me until very late that afternoon. So this proposal gets to NSF and NSF funded it. So thank you, Susan, and that's what Berkeley is about, and we all move in the shoulders of these wonderful people, faculty and staff, as well as students, of course. Then after I did that 1-year field investigation, then I formed a team and did 5 years of investigation to find out why this happened. So I will show you the result. And then I have concluding remarks. The designer, the architect, buildings have architect and structural engineer. Architect usually is well known, kind of like buildings attached to architect. Architects figure out the appearance of building, the aesthetic of it, where you should have elevators, where you should have staircases, what should be the walls be, the spaces, the bedrooms, the living room, basically the function of the building. But the structure of the building is what keeps it up. Those columns, vertical columns and horizontal beams and so forth, foundations are the work of structural engineers. It is always said that if you are a structural engineer, you don't want to have your name in the newspapers. When your name is in the newspaper, something really bad happened to your structures. No one appreciates structural engineering. The worst is actually plumbers. They are worse than structural engineers. No one wants to appreciate plumbers' work. It's not glorious, perhaps, for some people. But they're all professionals. We are all professionals trying to provide public comfort and safety. So it was so important that it was on the cover of Time magazine at the time. The structure was important, the building was important, and Yamasaki was important. Then, the structure, actually, the drawings are signed by Leslie Robertson, who was a graduate of our College of Engineering. But Leslie Robertson at the time was a very young engineer, working for Skilling firm. Skilling was a structural engineering firm in Seattle, and really the design was the brainchild of John Skilling. He was extremely adventurous, I would say, structural engineer, and you will see as I go through this webinar how daring in a dangerous way he was. It wasn't to say that he was courageous. It wasn't to say that he was genius. I wouldn't use the word genius. I would just use that he had this knack to come up with a structural system that will cost less. That's very important. It wasn't just some other structural engineers we have who really elevate structural engineering to a very high level as far as safety and cost, but safety is first. I'm not saying it was not for him, the safety first, but he would come up with all these completely unusual structures to save money. But Leslie Robertson was a young engineer, and he kind of like stamped the drawings. It's very common that senior engineers don't want to stamp structural drawings because if something goes wrong, they don't want their reputation and firm be endangered. So they usually have junior engineers to sign. It's another unethical behavior in my view. If you design the building, you sign it, not to sacrifice your junior engineers to lose their license or so. So this is the World Trade Center under construction. The World Trade Center towers did not need to obtain a construction permit. You might say, what? Because if you want to remodel your kitchen, you have to go to city and get permit. Why? Because you might sell that building tomorrow or rent it, and someone else is going to live in that kitchen. And if it is not according to the code, the people, the family, kids, everyone using that kitchen can be in danger. That's why society started to have this permit process about 100 years ago. It started with a fire in New York. So that is strange that these 210 towers did not have a permit, and they did not need to get permit. How come? The reason is Port Authority of New York and New Jersey, which own World Trade Centers and still owns World Trade Center, is a quasi-government entity. It was formed between the government of the state of New Jersey and New York. And it was formed by an act of Congress, actually. And it was exempt from the laws of both states, and it was exempt also from the tax. But it acted like a private developer and was renting World Trade Center like anyone else, but was not paying tax. It was developed for building bridges on rivers in New York, but eventually it ended up starting this World Trade Center. So many features, this is important. Many of you may not have heard this information that I'm going to tell you. And I'll tell you why you have not heard this. And some of you might be shocked at the end of this presentation that how come you have never heard this on TV or any news item. Many features used in the World Trade Center were never used before or after the construction of the World Trade Center. The Port Authority of New York and New Jersey did not need to even take the drawings to the city. They were the designers, they were the owners, they were the inspectors, they were the constructors, and they didn't have even a single drawing that was public. It's still the drawings of World Trade Center is not public, it's under the seal. I ended up being the only person so far that I have the Congress's permit after I testified before Congress to use the drawings of World Trade Center. And I did that study. The new features had limited test results and data on their actual long-term performance. These are like you're inventing something and just using it without any testing. It's like inventing a new airplane, I always say with one wing, and you're just flying people in it without testing or having a complete review by authorities. The Port Authority, as I said, was the owner in charge of design, testing, construction, inspection, and approval of plans. Now, let's look at some of the problems. The stacked elevators were invented here. In order to increase the area to rent, you can see the core. We call this middle portion center of the building's core. This is the plan. And it has elevators, restrooms, and so forth, and staircases. I've shown staircases in red and elevators in blue. The red one, we are going to focus for a while. So, for a few minutes. In order to increase it, the architect, Yamasaki, came up with this notion that until then, elevators were going from first floor to the roof. Now, if it's 110 stories and we want to have enough elevators to take 20,000 occupants up and down to the roof and down, it's going to occupy, usually the standard was 60% of the floor. They didn't like it. And what they were asked to do was do something to get more rent of the space. I don't want to use greed, but the profit is coming in now by corporates, by Port Authority, that we want this building to give us more rent money. So he came up with this idea, which you see in many buildings now, which is stack 1/3 of building on the other third and the other third. So what it means is that these red elevators are express. They don't stop in between. They just go from first floor to 46 and 78. And then you come out like the express train and local train. You come out and get into these yellow elevators, and depending on where you're going, you take one of those and go to your floor on that third stack or second or first. This was a very, very important development. It's not a negative development. And they ended up with having, let me see if I can show, yeah, this one. They ended up having, instead of 60% the core and 40% rent, 40% was core and 60% the donut around it was rented. The number of staircases was less than code requirement. You can see as built here, only 3 staircases. And what was then the code was that this building was being designed in 1960s, and from 1938 to 1967, the code requires 6 staircases, like this picture. I just put the staircases, as I thought would be more rational. And for the area, 1 acre area of the building. Then, and in 1968, it changed, but it required 4 staircases, like this. But they were designing it, so they changed the design and Yamasaki used only 3. This was the first important violation of code, that code requires 4, and if you have 110 story, you might as well do 6, but they went with violation of code and they used only 3. Then the number of staircases was less than the code requirement. The North Tower also needed elevators. So the North Tower needed the 4th elevator. Let me put this thing here. All right. The North Tower needed elevator because it had this major windows on the World Restaurant up there. Very large public gathering area. The South Tower also needed elevator, the 4th elevator, because it had this observation deck, which continuously people go from the first to the roof, and that should be separate elevator. It cannot be stopping in between the store. So basically that was another. So all tourists going up, they are using these elevators, 3 elevators, which is not enough for occupants stopping in all these floors going up. The underlying fabric was really to save. The staircases were narrow. 2 of the 3 staircases were only 44-inch wide. And the 3rd one was 56-inch. This one was 56, but those 2 were 44. The reason you have 44-inch, which was code requirement at the time, is that average shoulder of a person is 22 inches, and they thought one going down, one going up, it will be 44 inches. So they use 44 inches. But imagine 110 stories, people are coming down from up, 20,000 people in an emergency. It's not like nicely going to your meeting and walking on your own pace. 20,000 is the occupancy. They're coming down at 44 inch. If you look at 44 inches, almost, if you open your arm 44 inches, it's not much. It's like two screens next to each other I'm looking at. So that's what they did, and that's what we saw on the day of that tragic event, how people could not exit. Of course, the people above the impact area, they could not exit because the staircases were demolished. But the people below the impact area, they even had hard time to get out fast. So one person going down, as I said, will go up. Now look at this picture, as I showed before. That 44 doesn't fit the firefighters, does it? They have all kind of gear. They by themselves, they might be like 36-inch wide. And they are trying to go up while the other people are going down. So this is another concept. The unfortunate thing is this: the current New York City code, I checked like yesterday, requires only 36. Have we learned the lesson? 36 inches. Instead of making it like 62 inches, they have made it now 36 inches. I guess the wider staircases, this is my comment, would take away the rentable space, and the developers would not like it. But should the city code consider developers' desire for profit or safety of the public? And first responders. This is another picture that first responders on 9:07, almost 15 minutes after first tower was hit, they are gathering there to go up. With this gear, you can imagine even one person cannot go up with 44-inch staircase. Yet alone, think of the people who had wheelchairs. Of course, when the fire starts, elevators are shut down. So what about them? That's another story, what happened in this tragic event. People were carrying wheelchairs, so difficult. So all staircases were at the center. So 3 staircases, this is not, I'm not saying code says where you should put it, but it's very well understood in fire engineering that the reason you put these fire exits is people, wherever they are, can get one nearby. In this case, you are telling all people around the core that if there's fire, go inside the core and go down from one of these stairs. What happens is actually the most danger for fire is in the core. You have all the pipes there, you have all the electricity there, you have all the other storage there. The fire does not start here, it starts mostly here, and you're telling them that go there and go down. And you'll see what was the consequence of having those 3 stairs at the center. So one of the documents included in the NIST report, because later National Institute of Standards and Technology got a grant to study World Trade Center properly, and they reported that they got the document from Port Authority that showed Port Authority was eager to cut down on the amount of space devoted to stairs. How tragic that can be. That they're thinking of, can you cut 2 inches from the stairs so we can rent that 2 inch? In 1 acre is the floor. In the impact area of the North Tower, I'm usually showing North Tower plan. The other one was very similar. The staircases were 70 feet apart and were destroyed immediately when the plane hit. I'll show you, when the plane came from the north, destroyed all 3 staircases, and more than 1,500 people were trapped, and they, of course, perished in the fire or the collapse. In the South Tower, the plane hit on floors where the 3 stairs were about 200 feet. They were a little bit far apart. And one of the, and I met one person who had escaped from that damaged fireplace. He was a young person and he was retired from work, and I met him in LA when I was doing a presentation. These are pictures of floors. This is when it was empty for repairs. They were trying to repair the roof fireproofing. You can see it's open, and then only partitions were. Most floors had only partitions, and there is no. I'm not clear. I couldn't find if the partitions were fireproof. They required curtains to be fireproof and furniture, but I don't know if partitions were fire. That's why the whole floor was like a burning charcoal pit. So it was without firewalls. This is very important. There is certain code requirements, fire code, that you have to compartmentalize your floor, especially these large floors. So if fire happens in one corner, the other corner, the other parts of the building don't get affected. Even the smoke doesn't go there. They're all fire doors. But in this case, of course, there was no fire walls. At least I just did this, if they were planning to keep the configuration, they could put the fire and divide it into 4 and have for each one have 4 staircases, so everyone can have their own staircase and their own space. So if one gets fired, the other 3 are able to escape. Staircase walls were drywall. This is unbelievable. Staircases, I'm sure, if you look at your building, I mean, office building, even 4 or 5 stories, either it is concrete blocks, or for tall buildings, it's just concrete, reinforced concrete wall. This is the only building that I got to know that it was drywall. Drywall, just gypsum board. You can see the staircase. So what is the impact of it? When the plane hit it, the building, the staircase, of course, was nothing, like cardboard. And the plane went in and hit the large columns and exploded and spread the gas, the jet fuel, and started the fire. This is not allowed in any code, in anywhere in the world. I can't imagine. I can't imagine any even half-civilized country, the city would allow gypsum boards to protect people in staircases that are fire exit. In fact, the staircases should be pressurized to always keep the smoke out. The doors of staircases should be all spring, very strong steel spring hinges. This is no, they could do whatever they wanted, and they did to save money. In fact, when in 1993, there was this attack with car bomb, there was smoke in the elevators, and one elevator had 4 people trapped in it in mid-height. These 4 people, using the keys for the car, it's amazing, the keys for the car were able to poke into the wall and say, oh, this is gypsum. So they kicked it and they came out. This story was in New York Times. And it was very exciting story because everyone said that, oh, wonderful, they saved themselves from smoke because the elevator shaft becomes smokestack. But no one, including Port Authority of New York or New Jersey, or even engineering community, said that what? Someone could kick the elevator and staircase wall and come out? What was that wall? Concrete? And then, of course, they had to correct, but nothing happened. Staircases were not going straight down. This is amazing thing. In order to have like these big, probably conference rooms, meeting rooms, look, if you are coming down from the top, look what happens. You come down and get out in this floor. What is this floor? This floor is some corporate floor. So you're coming down, you go straight down, and after 10, 12 stories, you have to find your way to this exit, come down a couple of stories, go back, come down, turn around, go here, come down, find this, come down, back. Imagine, fire is behind you, smoke is killing you, and you're trying to find your way, and probably electricity even is gone, and you have in these floors that you've never been to find this path. It is worse than a trap. It's like designed to make sure you get lost and don't find your way out. So these are the movement of staircase in the floor. And this one shows very close Imagine you're coming down, you have to go there, come down, come back, go up, go to the right, turn left, turn right. Imagine in the panic, and especially if you have health issues, many of us have breathing issues, you are not, athletic. All of us are not like 20 years athletic, Olympic athletic. You are not going to be able to go down. This exit should be designed for people, not even average, people who need help. Fire exit means for people who are at the perhaps 20%, 30% of their health power, not the Olympic athletes. So this is tragic. The bottom 10, now, we look at structure. That was the cause of collapse. The bottom 10 floors have typical concentrically braced frame system. Those of you who are not familiar with the structural engineering, in structural engineering, we have framing system, columns and beams. Any building you look at, other than World Trade Center, as vertical columns, horizontal beams, like this 10-story of World Trade Center in front of you. On top of this 10-story, they have put this box. This is what has caused that collapse. So this is now going up, 7-story basement, 3-story plaza, and first floor, and so forth. Now they are putting this 100-story up. This was the strangest, the worst structural system that you can put against fire, and that's what happened. It did exactly what is expected to do and collapsed. Couldn't take that fire. The 2001 airplane attack hit the top floors with the steel bearing wall system. So this 100 floors, in fact, you could tell from the look of it, right? World Trade Center towers, the top 100 floors didn't look like any building. They told, architects didn't like it. They said it's like shoebox. And no one said, why is it like that? Why it's like a box? There is no window. There is no column lines coming down. That is because it was not framing system. Didn't have column, didn't have beam. It was a box of steel. It's like a box of steel, but it was huge. Steel plate. So in both attacks, I said 1995, it should be 1993. Car bomb attack and the 2001 airplane attack, the terrorists, in my view, may have been trying to collapse the North Tower onto the South Tower, because the one in front is North Tower. The first plane came and hit the North Tower coming from Boston, right straight at the center, trying to topple it on the South Tower, which if they were successful, it will topple on the Wall Street, reach the Wall Street. But it didn't happen because the tower box was so weak that the plane went in, disappeared. I was watching actually the fire live because a friend of mine, Steve Main, the late Steve Main, who was traveling very early from San Francisco, called my son, had the phone, somehow found my son's phone, and my son came to my bedroom and said, Dad, Steve says, get up and look at the TV. I got up and sat there. After the first tower was hit, I saw the second tower and the fire and so forth. And then, of course, I went to campus and rest of it. I was just answering the reporters and so forth. So I was surprised when I saw it, that I didn't know the structure because no one knew what the structure is. No one had any information about World Trade Center structure. I saw that the vulnerable plane, the tail even, which is very thin aluminum, went in. How come? The nose I understand, but the tail is very vulnerable for cutting through the steel beams and columns. The reason was, of course, there was no beam and column. So what is the steel bearing wall? Buildings until 1880s were masonry, and the way they built it, the walls around the building was masonry or stone. Sometimes it will go up Of course, it has windows, but it's small windows. It will go up. And there were some cast iron columns in the middle, and they will use wood trusses from middle cast iron columns, the blue ones, to the walls outside. And then they put plywood planks and wood planks, and then of course some gypsum or other concrete or anything on top of the wood planks, and you got your building. This was called bearing. But of course, you cannot build a 110-story building with bearing wall. In fact, I calculate if they had used bearing wall, the thickness of wall will be so much, the first floor will be just walls. So gradually, as you go up, you could have some space inside the walls to have rooms. But in any event, there is a system. This bearing wall system ended in 19th century. I'll show you who ended it and came up with this framing system that we use in millions of buildings. This is the tallest masonry building that is still alive and well, and in Chicago, 16-story monadnock building, which was built in 1891. It took 5 years, so it finished in 1896, and thanks God, it's so proud standing up. But if you look at the base, the walls are getting thicker and thicker at the base. In any event, this is the floor plan. The first floor has a very, very thick walls, as you can see, very small windows. You can see the window. And as you go up, the walls get a little thinner, but still, this is all masonry, walls around, and the little columns inside. So this is the tallest brick bearing wall that we have. What they did was, in the case of World Trade Center, they said that let's use bearing wall, that will be cheaper, but of course we can't use brick or stone, let's use steel plates. Imagine like this what you call the steel pit that we put gasoline in it or whatever. So that's what they did. But let me show you this one, because William Baron Jenny was the genius engineer who said that we don't need these walls, thick walls and small windows. What we're going to do is we're going to have these columns. You see here, the steel columns, steel beams, and open up the walls. We don't need the walls. The walls should be just for protection from cold and warm and theft and those things. The structures, the floors, should sit on these columns. The weight goes down to foundation. So that is the first building that is the home insurance building. Unfortunately, it was demolished. I wish they had kept it. It was demolished years ago, I think 1931. Yes. So now all buildings almost, even your home has vertical wood studs to get, and horizontal studs, joists to get the load to columns. There is columns, and then you put gypsum boards as wall and so forth. So what they did with the steel. So this is the masonry bearing wall. You know, this is the monadnock building. And what they came up, this is the steel bearing wall with columns inside, right? They are building it here. This is a steel bearing wall. They invented it, and I wish they were not, because we would have many of the residents alive today. And of course, tragedy will cause a lot of casualties in the plane and so forth. But still, it will not be just the building completely evaporating and collapsing on occupants. This is the wall, and this is, you can see the exterior wall. These are pieces of wall fabricated in Japan, 3-story, came to the side. They were bolted together. It was like a Lego, exactly like a Lego, and collapsed like a Lego. They fell apart when. And the floors, it's very interesting. The floors were steel trusses. These trusses are used in like Costco's of the world, Safeways. These are for long spans, but low rises, because they are very, very vulnerable in fire. They have very large area compared to their weight. So fire completely easily gets them to high temperature and they collapse. The bearing wall collapsed like a house of cards. It was the house of cards. These little bolts would work if the steel was cold and could carry the gravity. But if the steel get hot and could not carry the gravity, they buckle in the fire floors and the whole top fell on the bottom. So let's continue. I miss showing graphs in classes, so I put this graph. I apologize. This is showing the change of strength for material that we use. The red is for steel. So the dark blue is for normal weight concrete, and the light blue is for lightweight concrete. This building had lightweight concrete. So all of them, concrete and steel, drop their strength from 1 to almost half when we get to 1,000 degrees Fahrenheit. If you want to remember a number, it's just 1,000 degrees. In 1,000 degrees, the strength has dropped. So you have this weight on this, and you calculate this strength. But if the strength is reducing at one point, the load becomes equal to strength, and after that, it's going to collapse. The strength is reducing, but the weight is the same. So gravity is not changing, but your strength is changing. Very simple thing. So these are some of the pictures I took, those Lego pieces, these pieces of Lego. The reason you see it's not just plate, because this is the plate that's carrying the load, but plate buckles easily, so they have put these boxes behind it. It's strange enough, look at this cross-section of box. Fireproofing was outside the box. The left is inside. You didn't have fireproofing. Why do you put fireproofing at the elevation of 110 story outside the steel? This is the floor. They built this floor and brought to New Jersey. Overnight, they shipped to New York, and in the day, they put up. Everything is included. But the joist is very, very vulnerable. Now, the walls are vulnerable. The joist is vulnerable. There is no column, not on the perimeter. So there is no luck here. No one can help you. It was doomed. This is for the floor truss. This is the bar that if it fails, the whole floor drops. This only single bar is holding the 60-foot long truss, 60 feet. And look at the fireproofing of this bar. Do you see fireproofing? There was a famous saying in New York that if you are inspector of the buildings, the high-rises in Manhattan, you better know how to swim well. The joke was that if you go up there and you're inspecting and suddenly you find something like this, there is no fireproofing in this critical member, you will be pushed out from the window, and you better know how to swim in Hudson River. But in any event, the pre-collapse photo shows clearly that this bar didn't have fireproofing. Even if it had the fireproofing, I get to it, it was something that in those floors that had fires, the fireproofing would drop anyway because of the impact of, and there was no sprinkler system that was working. So the plane hit the sprinkler system in the middle. So this, as you can see, the Legos are going up, I call them, and the floors are being put on those little pieces. This is not a frame. This is just building house of cards. If gravity is there, if strength is there, we are fine. If gravity increases, you put more load, or strength is reduced, it is doomed. These are some pictures of fireproofing. There was not much, and whatever was gone. So let's look at the collapse. Why it collapsed like this? This is the plane coming from north, hitting the north tower. The 3 staircases were gone. The plane from north also came and saw that tower is on fire, but it's not collapsed. So turned around, went south, and hit this one from the south. But it hit an angle, so these 2 staircases were damaged, but one was damaged but was still passable. So this is what happened. The plane comes in, gets in from the curtain wall outside. This is really curtain wall, we call it. It's a very thin wall. Gets in, hits these large columns in the middle. And of course, break some columns, but also the whole plane is disintegrated, and the jet fuel starts fire, and the floor joists are collapsing. And when they collapse, these walls don't have support, they buckle. When they buckle, the whole 26 floors or 34 floors, like a big weight, drops on the lower part, and like a hammer, hits down. And because there is no column, no beam, you don't see anything other than floor concrete and gypsum board being disintegrated and dropped. So this is what you see. Sometimes you see some wall pieces, but this is really the gypsum board of the walls and the lightweight concrete of the floor. This is the pictures that my photographer, I hired a photographer in New York, local, and they took, and these are some of the pictures. We took thousands of pictures, and I came back and analyzed them. So here I am investigating this. First, I went to site. First, I was outside the site doing the investigation, which of course, first I went to the site. I was able to enter and paid my respects and prayers, and it wasn't the place to stay and investigate. It was a horrible situation. It was still on fire for 2 weeks. Some nights in the hotel, which was Tribeca, very close, in the kind of cordoned out area, I was staying with the first responders. Some nights we would just put on our 7-degree masks to protect against anything. I got actually some sickness on my shoulders. I had to do surgery, but fortunately it was not cancerous. It was just the infection of old germs that I was exposed in these areas. But I was going to New Jersey because they were taking this steel to New Jersey, they washing it and getting DNA and other personal stuffs out of it, and they were storing here. So I was inspecting there, basically, you can see. This is the first time I arrived, and I was in this Tribeca hotel. They were bringing these putting out. Other trucks would come and take them because the trucks coming from inside, they didn't want to send those trucks to go to New York. So there was a transition. So I was in front of this hotel, and they didn't have my key even. So I asked, they sent me the keys from Berkeley, and I did. So these are some of the steel that I was dealing with. There were 200,000 tons of steel, and I think I did inspection of 40,000 tons. But rapidly, they were chopping and sending it to Mexico and China for melting. And this was the Port Authority's decision to make sure no evidence is left of these structures to show what they were. What happened very interesting was that victim's family formed a group, and this is Sally Regenhardt. Now she's like my sister. Her son, Christian, went in. He was the starting firefighter, went in, and he was one of those who they never found the DNA. So and Monica Gabrielle, her husband, perished in the floors above the fire while they were on the phone, on the cell phone. So the building collapsed when they were talking actually on the cell phone. As I said, this is a little bit of tragic, but we have to be respectful, but at the same time, the facts should be said. So they formed Skyscraper Safety Campaign to fight against engineers who did this thing and make sure this never happens. And I ended up being their advisor with several others on different fields, fire advisor, that this and that. It was a very great honor for me to do that. And here is Sally with Christian in good days. Now, it comes to this. Not only the engineers who designed the World Trade Centers, in my view, did follow the orders of the client to make the building as cheap as possible, as low cost at the expense of safety. But then came the investigation of collapse. At that time, I had my grant from NSF. I was in New York, staying in a hotel and doing my investigation, collecting, as I said, Tribeca Hotel, collecting my data, pieces of steel, concrete to send back to Berkeley for further investigation. That was the whole grant of National Science Foundation, to collect the pictures and material to bring back so other researchers can study it. ASCE, American Society of Civil Engineers, came in, contacted FEMA, which was in charge of World Trade Center response, and proposed to study it. And FEMA ASCE Building Performance Assessment Team was formed, and they issued this final report. Actually, they called me and said that we're going to have our meeting. Would you accept to be on this team? I thought, well, I didn't know what's going to happen. I said, fine. I've been here, I've studied, and it's good to share the findings with the CE team. I accepted. We had a phone, we didn't have Zoom in those days. We had a phone conference call, and the first thing they said at this conference call, ASCE, American Society of Civil Engineers, executive director who was running the show, that, look, no one should talk a word about what they see as we go forward with the investigation, other than what we are going to put in the final report. And also, I realized there are people on this team that should not be, and I'll get to that. So I told them that, right there, actually, I didn't continue the session. I said that I'm sorry, I cannot stay because I'm sent here to get by Berkeley to get investigation for National Science Foundation. The only rule National Science Foundation has is go get the research done, make sure you do your best to find the facts. As best as you can, only facts. After you're convinced that you have the facts, then do your best to publish it as widespread, disseminate it as widespread as you can. Only two rules. Don't think of what will happen if I publish this, what will be the consequences, what this, that. Absolutely not acceptable. And then I said that I cannot do that. You're telling me to violate National Science Foundation. Then I added that, look, we have a dean that, I didn't say the name, I said that, look, we have a dean that I go back and I say that, look, I have this National Science Foundation, and I kind of like agreed to be part of a C team and not publish anything. Immediately, he wouldn't take even faculty meeting. Immediately, he would file with provost and chancellor to get rid of me. Berkeley, no university will accept the faculty who's giving, freedom of academic freedom, and especially if I think I got this project mostly because of Berkeley. I had, of course, experience with studying buildings and protecting against terrorist attack. But I always say that 50% of whatever I could achieve was because of Berkeley, not only just a name. You all know, I just stop here. You know what Berkeley gives you. Berkeley gives you the ability to bring the best of yourself and everyone around you. That's my experience of 30 years in Berkeley. Anyway, this is the problem. This is the first page of this report. It shows the members of this team. I'm not there because I resigned the first meeting. There are two people here I circled. Let me make it bigger. The first person is John Magnuson, partner, Skilling Ward Magnuson, Berkshire. You may not know him, but Skilling, I told you, this is the firm that actually designed the World Trade Center. And he says partner, but he was actually higher than partner. So he was one of the bosses of this firm in Seattle. And now ASCE, with taxpayers' money from FEMA, is investigating the most important collapse, killed 2,752 people. And now ASCE allows the designer firm to stay on this investigative team. If this is not conflict of interest, it is, in my view, a crime. Because of the importance of the case, we are trying to find out what happened here for almost 3,000 Americans. So, PNC managing partner, Leslie Robertson Associates. Who was Leslie Robertson? I told you, the engineer who has his stamp on the drawings. So Leslie, Sultan C actually is the wife of Leslie Robertson. Leslie Robertson was the engineer who worked with Skilling to design the World Trade Center. Now they have a firm, Leslie Robertson, and the wife is on this team to investigate what they have done. In my opinion, the FEMA ASC BPAT signing of the non-disclosure. Oh, there was another thing. Yeah, we have they said that you have to say nothing about it. With the no, sorry. The most important thing was that ASC actually signed a non-disclosure agreement with Port Authority to get the drawings that they will not say pretty much anything that will give Port Authority legal exposure. In other words, they're not going to say anything bad in this report. Can you believe it? This is happening in America, that ASC getting funding from FEMA, probably FEMA doesn't know about this, and they get the money. I think it was 1.5 million. They go to Port Authority to get the drawings, and Port Authority said, we can't give you the drawings. You have to sign non-disclosure. So it was very serious conflict of interest and very serious giving away your freedom to tell the truth. Then came the outrage of victims. So Sally and Monica went to Congress and complained, and that's when actually George W. Bush had this whole process of allocating $8 billion to victims' families and so forth. But this group of families, 50 of them, which I was on the honor of being on their advisory team, did not want that money. They said that we don't want to accept the money. And they did not sue anyone. And then they said that we're going to dedicate ourselves to make sure this doesn't happen again. So they went to Congress, and Congress had hearings. So the next thing is, I was invited to the hearing. I'm here. I didn't have beard. I wasn't as distinguished as I am now. But in any event, there is the fire engineer, there's the FEMA director in charge of, associate director in charge of this case, and NIST director, and so forth. This is the Committee on Science. For 4 hours, we testified. And Chairman Bollert was the chair of this committee. I was the only one actually who had information. The rest of them were not there to give information about the site and collapse. So after that testimony, Chairman Bollert turned to me and said, Professor Astaneh, what do you need to continue? And immediately I said, I need the drawings. The drawings are under the sea. Of course, I had looked at the drawings because Leslie Robertson, at that time we were friends actually with Leslie Robertson, invited me to his office and told me that the drawings are in the second floor of his office. All drawings are ready for FEMA use, and I can use it, but I should not make Xerox copy of drawings. And what I did was I took tracing paper and I traced some information every time I was there. I usually was there from 6 to 8, and I would go to New Jersey from 6 to 6 to do the day field investigation. So in any event, and I answered that, and he turned around and told FEMA associate director that send drawings to Astaneh. Before even I got back to Berkeley, to Alamo, our house, the 15 CDs were in the FedEx. I sent it to house so it doesn't get lost because, so anyway, so after our testimony, a bill passed by Congress and they established this National Construction Safety Team. So NIST, National Institute of Standards and Technology, investigates the future collapse. That was our testimony. I wrote very much about supporting NIST being it, not ASC, which is a private company and apparently not very ethical. So all the information I gathered from it is here. The College of Engineering CRESC library has all the information. I checked it last night and I got this URL. I don't know. I just copied URL and put it here. If you click all the photos, I think it was about 8,000 some, all the reports, all the documents I gathered, data is there. So the last part is really the study we did from 2002 to 2007, 5 years. It was not funded. I always say that it was honorary funding with the Scottish Rate Safety Campaign. I did this basically based on promise I made to Sally when on one of these occasions I was in New York. We always met, these victims of family, this group, Scottish Rate Safety Campaign, with architect and fire engineer and others, 10 of us who were advising them. And I told her that I have the drawings, I'm gonna investigate and see what's happening. And Chairman Bowles actually told me that you are free to use it. So I did, and here are the results. What I did was this. On the left, you see structural framing, floor framing of the existing as-built World Trade Center. It didn't have beams and columns. It was just joists. These lines, blue lines, are joists, steel joists. And perimeter is just those steel plates. You hardly can see the red line. This is what I designed. I designed buildings, and I've done quite a lot of consulting. I do that. That's my job. I designed this building as any other buildings, like Sears Tower, like any building you see, like a Bank of America building or any building, steel building that we design. I designed it standard, not for airplane, nothing. Just it's a building we design according to New York Code of 1968, not even the recent. So then build a model of them and bring the airplane model and hit the building and see what happens. Fortunately, we had very detailed model of 747 Pan American that was exploded on Lockerbie, the tragic event then. But the company that we used, they had it, so we got it. And we built the 30-story where the plane hit. This is 30-story height. So on the left is the plane hitting the existing, at that time, as-built dock. See what happens. It goes in completely as you saw. We had the angle right and pitch and so forth. So it's very detailed. This software that we use, we use 3 software, each one is $100,000. But it was donated. I had a classmate from Michigan. He saw me on TV and offered that our company, this MSC software, whatever you want, we'll give you. This is the highest complicated software, sophisticated software. They use it in car crashes now in Detroit. So we use that software, and he sent Tunga. Vijay Tunga was his engineer to help us to use the software. And those are, and this is my friend Haydari, Casey Haydari, who did this donation. So the plane goes in, cuts the tin plate, and goes in completely. It's so bad that the engine comes out of the other end. Actually, the engine went 2 blocks away. On the right is, don't worry about this time kind of like sand clock. That's the shade of these colors that happens in these programs. It's just exactly columns and beams and nothing extra, just the code. And the plane comes, the same plane, hits it. It looks like it's going in, but it's being shredded actually. And the engine even cannot get in, this engine. The other engine gets in and hits the concrete wall and can't go beyond the concrete wall of the staircase. So the staircase will stay safe. Most of the fuel will be dropped here because it's all shredded. It cannot break the columns. Only one column broke because the nose hit it. Nose is very tough. Okay, so we actually did the 747, which we had exact model. And you see, if they had 747 hijack, it will just collapse the building immediately because it cuts the whole width of the building, 220 feet. That's the wingspan. And the building cannot stand. But on the right, this typical code design, some engines are going in, but still the wall is keeping the engine. It's not taking the important thing is that it is shredded outside, that the jet fuel drops outside. Just for the sake of seeing what would happen if they had just a little 18 passengers G-15 jetliner. this is on the left. The plane comes, goes in again very easily. Look at that. The whole plane goes in, even that little engine, little plane, right? It's all now disintegrated. But even that little engine, the engine is flying here. But if you had designed it according to the code, the little plane is coming in. It's like a fly. It's completely shredded and it's stuck. You know, the engine hit the wall, concrete wall, and it is flying out. So with that, my main conclusion is that this study found that the root causes of the fire completely collapsing the two structures were not following the building code to save in construction cost. If they had followed the code, they would save people, but they didn't follow the code to save in cost. Using the unknown steel bearing wall system, which is very vulnerable to fire, but costs much less than well-established structural systems in the design codes. Not providing sufficient fire protection system for the structure, again, to save in cost. Not providing necessary and protected exits for the occupants in case of fire. That would reduce the rentable space and renting cost. With that, I thank you for your time. I'm sorry I went way beyond, I think that, but I will be happy to answer questions. Donald?
All right, thank you very much, Hassan. That's a very thorough and convincing analysis of what happened. So let's see what we have in the questions to ask you. Okay. There have been questions about adequacy of fireproofing of structural steel, and if so, lack of which could cause collapse. Has there been research on this issue or factor as lessons have been learned for similar structures?
Well, one lesson that was learned was that until even now, we are still doing that. Fireproofing of structures is done by architects. I think that's completely wrong. Architects don't know fire engineering. It should be done by fire engineers. And the only thing architects do, even for 110 stories, that they specify hours that fire can go on without structure collapsing. So you see the problem. Architects don't know structure, but they are deciding how many hours we should put protection. In this case, the protection was 3 hours for the column, I mean walls, and 2 hours for the other elements, but it didn't actually matter because the building was so vulnerable. But the lessons learned is that we should move towards performance-based fire engineering, which means, like structural engineering, fire engineers should be hired, not architects. Fire engineers should be hired to do very well done analysis of fire progression in the building, this, that, and specify what fireproofing should be placed on what. This is tragedy that our architects have taken this duty, and of course they are paid to do that, but they shouldn't be. They should just, this is unethical in my view. They should say, this is not our expertise, go find a fire engineer. And Berkeley actually is one of the most important fire centers engineering. Most fire experts refer to Berkeley and so forth. Another thing that has happened in Japan is they are now producing steel that instead of 1,000 degrees, it gets to the reduced strength in like 1,500 degrees. That gives you more time. By then, either the fuel is burned or the firefighters get to your fire. That's very important development. So you don't need actually fireproof.
I see. And another question asks about usually you see that fire and flames move upward in a building, but in the World Trade Center collapse, the fire started high up where the planes hit. How did it come that the fire migrated down? Or was it just smoke going downward?
I don't think fire ever went down. What happened was the floors collapsed and the floors that had fire dropped 2 floors down, and then you could see, oh my God, now like 76th floor was hit, and now after 20 minutes you will see that 75th floor also windows are showing fire. That was because the floor dropped from 76th floor dropped to on top of 75th floor.
Right.
So that was the initiation of collapse. When the floors dropped, the walls had very long height and they buckled, and the whole top floors fell down.
Thank you. Another question, was there any structural testing before construction? Were there any records of such testing?
There was very interesting testing. This building was so, I heard this from Leslie Robertson. I went there like a week later after, and first day I went and met Leslie Robertson in his office. We went to lunch and so forth. And I had a very long notes. I was with him for 2 hours almost and took a long notes. This is very interesting. What happened was this building was so flimsy. The only word I found is flimsy because it didn't have columns and beams to have stiffness, that it would vibrate. It would vibrate if it was built, and the people will get seasick. When the high rises are not having enough stiffness, the wind comes and get the resonance and starts moving, but that moving is making usually people who sit, like professionals who sit a lot, or these days we sit all of us behind computer, then you feel and you get seasick. So in order to check it, they decided that we need to find the frequency, that if building that has frequency, it can get resonance with the wind, and that frequency actually we use now in design of all tall buildings. So what happened was this: they could not test this building and announce to newspapers that we are testing, we'll test in order to avoid vibration. They would say, what? Why should building vibrate, right? So they go to Oregon. They rent a 2-story building. They set up in the 2nd floor an eye kind of examination shop, the whole thing. And they announced that we are giving free eyeglasses and examination, right? The 1st floor was actually a laboratory equipment measuring the frequency. So they had the chair of this eye doctor as a vibrator, like a testing lab, right? So you go there to check your eyes. These days, you cannot do these days, right? You have to tell the patient what you're doing with them. So they use them as kinetic. Anyway, in the interest of time, so the guy sits there, they are examining his eyes, and suddenly they start vibrating the chair with increasing frequency. At one point, this person, doctor, I feel like dizzy, I feel something. And they said, no, I think there was maybe minor earthquake because Oregon gets earthquake. And then they got the data, right? They did that and they got this 2% G, which we use throughout the world. If the building has 2% G, kind of like acceleration, it will vibrate. So they saw that, yes, this building will have it and it will vibrate. So they went to 3M and they told them that they design dampers for us. That is what viscous dampers is, which millions of it is used in structure. So they were trying to reduce the cost and they were going to these tests. So 3M created this damper, but when I actually took one of those dampers, I have it in my house. I'm going to give all of them. I'm committed to Smithsonian. These, as soon as I get time, I'm going to ship them to Smithsonian. So these dampers were dried, and these are the first dampers, viscous dampers. They were rubber at the beginning, but when I got one of them back with me, they're like solid rock. They're not dampers anymore. So they were just stuck, and that's why building was not moving. It wasn't. So those were the tests, but they did something about connecting the floor to the joist, and they came up with a very cheap way, and they tested it, but that didn't work. Definitely didn't work. The test was meaningless. But other than that, I don't think there was any test of the system and fire. They should have done a fire testing in like there are 3-4 places now in Canada. The famous one is the lab is ready to accept your piece and test it according to standard and say that this wall will last 3 hours to 2 hours. No, they didn't do any meaningful tests.
Okay, I have a question here about have your findings been reviewed by others, and what were the findings of the FEMA report?
The FEMA report has a lot of concerns. FEMA The finding of FEMA report? The finding of FEMA report was the ASCE FEMA report or NIST? I thought you said
The ASC one. I think
ASCE FEMA. Yeah, that was horrible. Actually, Congress told ASCE FEMA that I should be with two other fire investigator and other faculty. We should review their report before they release it after testimony. And basically the report said that these buildings were so good. Can you imagine? These buildings were so good in fire that they lasted 1 hour and one lasted 1.5 hours. These were designed to last 3 hours, even though the design, let's forget about architect and stuff. You said that this building is going to last 3 hours. They said that this was so good because they were basically giving it to non-engineers, the report. The sad part was that the whole profession, including ASC and the engineers, in my view, are, let me tell you, actually, when I presented our results in 2007 for the first time at the Sibley Auditorium, Professor B, he's retired now, was sitting there, and he asked the question that, why ASC did this? Why ASC said that everything is fine. There was no problem. What you should do is you should prevent planes from hitting buildings. And that's why we have all these TSA. Anytime I pass through the airport, I said, God, this is what our profession had done to people. Of course, you don't want the planes to go to the plane. But this building was exception. If that plane hitting Sears Tower, of course the passengers in the plane will perish. Of course, but it will not be complete collapse of 3,000 people lost. In any event, so Bobby said, why do you think ASC did this? And I, just being, I'm very honest in these cases. I don't look at who would like it, who would not like it. I said that because they have moral corruption. This is because of moral corruption of ASC. That's exactly what I said. And I believe it's moral corruption. Because ASCE executive, when I resigned from the team, had left a message in the phone. In those days, we didn't have iPhone. So in hotel phone, he had called and left a message, which I still have it. One day I should put it in a book or something. This executive director of ASC in charge of this study, taxpayers' money. He has a long discussion with me that, Hassan, you shouldn't say these things. Why are you telling New York Times that this building was this, that? You shouldn't say a word that reflects negative on the profession. Can you imagine? 3,000 people are dead. I'm sitting there seeing all these things, and he's telling me that don't say to public that these buildings were actually bad design, which of course I threw away. I didn't throw away the tape. What I did was I took my camera and then let it run and tape the recording, and I have it because it's very important that it should be published to show American Society of Civil Engineers with almost 100,000 members, when it came to safety of Americans, at least to tell the victim's family what happened. The most important thing, as you know, when something happens to your loved ones, you want to know why. And they denied that to victim's family. And if I get a chance and I live enough to do, I plan to have at least a short book and these there, that our profession was morally corrupt when it came to profession, because other engineers also kept silent. No one has said that World Trade Centers did not have frames and system. This was a system, no one. Even when I say, they kind of try to contain. So
maybe we could fit in just one very quick question. It's just because there's a couple more here. Maybe one more very quick answer. You mentioned that this was the only major building that used the Skilling design. It says there were many decades between the design of the World Trade Center and the 9/11 event. Why, which revealed how bad it was. So why was it never used again? Otherwise, is it because it couldn't have passed code anywhere else except by this unusual circumstance?
Yeah, actually, there were some other places in Tulsa, Oklahoma, that Skilling and Yamasaki did use this system in shorter buildings, and they convinced the city that, look, this building, we built 110 story in New York, this, that. But no other engineer or designers used it because they looked at it and it's not in the code. They didn't do it. So there were some after World Trade Center, not as high as the World Trade Center, maybe 40 stories. And they were only designed, maybe 2 or 3. They were designed by Yamasaki.
Well, there are many compliments to your presentation, how interesting and fascinating and informative it was in the comments. So maybe you'll see that afterwards. We have to stop now. We've reached the end of our time. So I want to thank you very much on behalf of all of us for this wonderful explanation. So we really understand what happened in the tragic day.
My honor and pleasure.
Right. Thank you very much.
Thank you.
Bye.
Thank you, everyone. Thank you for your
Bye.
time. Thank you, Ken.